Guys, for the slow start, I was making chicken. I'm going to go check on it here in 2 seconds, so I'm just going to talk for a minute while the stream catches up. I underestimated the size of chicken breasts here in America. I feel like they keep getting bigger. Like, if you saw the size of chicken breast, it didn't come from a regular chicken. It came from some sort of weird mutant chicken. So, anyway. So, in a minute or two, I'm going to run just to make sure that guy's done, but we should be able to get started. Doop-de-doop-doo. That's my theme music. That's my intro music. Doop-de-doop-doo. Alright, so this week is the chain of responsibility. What's my rant? Okay, so I came across a really good video about BDD, behavior-driven development, and it's from the maker of Cucumber, so it's a bit biased towards that tool, I guess, right? Like, you know, he's got his own vocabulary for things, but I think it does a really good job of kind of expressing the frustration that everyone runs into when dealing with projects, especially in Agile. So 17 minutes for that video. Highly recommend it as kind of just get a cup of coffee or a beer and enjoy. For the chain of responsibility pattern, what we're hoping to get out of this pattern is to add some flow control to our application. So we did the state pattern, and the state pattern is great. It allows us to really standardize what we mean by the state of our context. So let's go over to the code for a second and kind of catch up. So we've got this abstract class called GameState. And so what we're suggesting is that for every state that the game is in, it should follow this basic contract. In our case, right now, we're only interpreting. But we also talked briefly about how changing states can be an expensive process. And so to give that a little more context, let's say that every time we come into a state, we want to public void load the state. And we'll make this abstract. And we might want to just interpret something, that's fine. We also want to abstractly void display a prompt. And then let's just say abstract void unload state. So super simple for right now, but we're assuming that whatever's going to be controlling this should be able to rely that when we enter a state, there's some sort of instantiation, whether you're loading resources, prepping other modules, or what have you. And then for our needs, something very specific to our state is that we want to be able to interpret. Another very specific thing is that we want to be able to display a prompt. And so we're putting the onus, the responsibility to display the prompt on the game state. So you tell me what you need game state in order to interpret. So let's put this above, because we are designing a flow, right? So load the state, display the prompt for that state, assuming you're taking some sort of input, interpret that input, and then we'll say public abstract void display response. All right, looking at chat real fast. Hey Stu, hey Smudge, hope things are well. So we've got this basic flow for our state, right? That we want to load, display prompt, interpret, display response, and then unload state. Now we don't want the state itself to be responsible for its own flow. It's not necessarily that it'd be difficult to do, it's just it puts a dual responsibility onto our game state. And it makes things very complex because in our abstract class, do we govern the flow there? And if we do, then we have to keep adding this branching logic for every state that we add to the game. So it's not very modular. It gets very sticky with a bunch of ifs and else and what have you. We could solve that problem with more architecture via like a strategy pattern or something similar. But we're going to take a step out, right, to the actual game context. And we want the game context to be able to have some mechanism. This is where we're going to add our architecture. So with the chain responsibility, we are moving back from the game state and saying, what's the flow for the context itself? And when we get into it, hopefully it'll make a little bit more sense, but the general idea is the game context. I'll also open up a notepad. If we're looking at the game context, and we say that we want to have handlers, and one of those handlers is going to be a loading handler. So when the game context is created, instantialized, whatever have you, and we hit start, we hit go, we do whatever we want to do to kind of kick off the game context, the first thing it's going to do is say, okay, loading handler, what do I need to do to load? Well, inside of this loading handler, it could pass through multiple states. It could revert to a previous state before returning. So we're doing this flow control. We're putting that responsibility on what we're calling the chain of responsibility. And so while in a very simple architecture, they're going to line up nearly one-to-one. So in our case, we're probably going to have one handler per game state. As the game becomes, or the application becomes more complex, there's a good chance that loading handler is going to do more than just execute things against the game state. So let's go over, because I'm talking. Ooh, I don't have a lot of resources here, so let's go ahead and just Google. And we'll just do chain of responsibility pattern in C#. Oh, I'm just away from the screen for 2 seconds. Like I said before, I've got chicken on the stove. That's my bad. But okay, actually, I blame the mutant farmers out there that are creating these abnormally large chickens that are throwing off my cooking time. That's who I blame. Be right back. Alright, so the chicken's fine. It's not quite done if I turn off the stove. So if my wife comes home, I have to break just for a second. I'll probably just yell, honey, don't eat the chicken. It's not done. Whew. Alright, so chain responsibility. Definition is to avoid coupling the sender of a request to its receiver by giving more than one object a chance to handle the request. Chain the receiving objects and pass the request along the chain until an object handles it. Okay. As usual, these definitions are not very helpful. But as we can see, it's a pretty simple UML, right? And if we scroll down to the main bits, all we really care about is this abstract handler class and set successor. So we're going to go and start there. So we're going to come back into our common project. We're going to add a new item, and it's going to be a game handler. Make that a public abstract class because, again, we want to create multiple handlers that inherit some base functionality from this game handler. And we can safely just copy this code and make our little adjustments. Protected game handler. Hang on real quick. So here we have our protected property that is our successor. So as we chain things together, we need to tell every handler what link to call next. So we just have our successor. And if we do, let's copy this guy, change that to game handler. And so all we're doing is taking in for set successor is taking a successor and assign it to our successor property or field. Okay. And then lastly, we have a handle request. And right now we don't really have anything we're passing in. We're not going to make it an integer, that's for sure. Let's go ahead and make it the game context. Okay. So as it stands, this is fine. If I come back over to our core and I add a new folder for handler, and then I throw in a new class, we'll call this load handler. Make this guy public. Have it inherit from common dot game handler. The first thing it's going to do is tell me that I need to implement this member, which is the handle request. Okay. So, kind of blew through that kind of quickly, but we've got our concrete handler, which is our load handler, and then we have our base class, our abstract class, being the game handler. So with that, we've more or less implemented the pattern. So if I come in here and if I've got my game states, because we're going to be matching them. Oops, not there. I've got load player, and I've got game selection. So I'm going to add a new class and call it game selection handler. And then another one for game command handler. And let's do this, and we'll hold off on inheriting for right now because we changed some things. So it'll have to be a pain to go through. Okay. So right now we don't, in terms of handling the requests, we don't really have much to throw in there. Let's go back over to the game handler and let's put in a public void. I'm just going to say process. GameContext. You're not going to see this in a lot of the examples, like this very, very simple one. But I like to bake in a little bit of functionality. I know what my flow is going to be, and I like my specific handlers to also know what that is. So, let's see what we've got available to us in terms of game context. So we do have our game state. So for the base functionality, let's say that my game handler knows the first thing it needs to do is load the state. The second thing it needs to do is display the prompt. GameContext.GameState. And the third thing is going to be interpret, and we'll throw in the game context, and then we're going to do a GameState dot unload the state. So we know we want to do these three things. And I'm going to close some of this stuff. Just closing files, get a nice clean workspace. Nice pretty workspace. Making changes in namespaces. Okay. So, every time that a handler is called, it's going to go through this basic process of loading the state, displaying the prompt, interpreting, and then unloading the state based off the game state. And we still have this abstract handler request, right? So, we want to give the handler a chance to do whatever it needs to before anything else happens. So we're going to call handler request GameContext. So that's our basic flow. Super, super easy, right? That's all we're doing. So what does that buy us? Well, we come over to the problems we had last week, which was we didn't have a smart way to loop through our states or even display these prompts. Now we do. And if our flow ever changes, we only have to change that flow in one place, which is also really nice. Hang on, I feel like I'm missing something. Hang on, looking at chat. Unload is one word. I bet it is. I bet because my grammar is it's horrible. Man, let's change that there. Change that there. Okay. It's wrong anywhere else, now we'll see it. Okay. So, it's skeletal. We're not going to do much with it, but if you ever needed to defer more responsibility to the specific concrete implementation of that handler, you could do so. You could wrap these in all kinds of extra methods and then wait to call them inside of the handler. We don't need to do that yet, so we're not going to. We're definitely going to set up the framework to do that. Okay. This looks good. Thinking. Okay, so let's look at our game context. Previously, the only thing we had available to us was interpret. So we threw a little facade over interpret to clean up the call, but now we've got a handler available to us. So let's go ahead and add it to our properties. So, just know all this. We also want to have a game handler. We'll just call it game handler. Get set. Cool. Just going to copy that guy. I'm going to get my game context. Public. Game handler. Everything's happy. And we're defaulting our game state to load player state. So inside of our constructor, we're going to want to go ahead and set up our chain of responsibility. So if we say that the game handler is equal to a new load handler, then we set our first link in the chain. let's go ahead and populate our other handlers. With not a lot, but enough to kind of prove this out. Go ahead and copy this stuff. Get rid of the using tags we don't need. Come over here. Paste that in. Get rid of some using tags. Boom. Okay, so now that we have our three handlers to go with our three states, we can come back over to our game context, and then we want to say, hey, game handler, and now we're talking about the load handler. I want to set your successor. I want to make the next load in the chain. And hang on, let's go ahead and do this. Var game selection handler is equal to new game selection handler. I want to set your, so when the load handler gets done, it's going to call the game selection handler. And then var game command handler is equal to new game command handler. I'm going to say that the game selection handler, its successor, is going to be the game command handler. Okay. So, and I'll put this stuff, I'll put my declarations all together. I never know where to put these things in my load nut, because it gets kind of weird, right? Because we're creating a link. Things are, by the very definition, it looks like this. This is what a chain looks like, and so I don't think it's any surprise that in our code it also kind of looks like that, and it just looks a little woven, right? So I'm declaring, I'm assigning here, declaring here, assigning here, right? So it really makes that representation of a chain, for better or worse. But it's nice when life imitates art, so to speak. Okay, so now these are all set up to throw exceptions left and right. But if we remember back inside just a few minutes ago, I put process in here. So back inside of my game context, before all I had available to me was interpret. Let's go ahead and replace that. We're going to do the very same thing we did before. We're going to do a little bit of a facade where we offer up a method to the user or the programmer, the consuming layer, as an API. And then under the covers, we're really calling something else. But to simplify that API, we're creating a facade. So, game handler dot process this. It's pretty much the same call. What we've done is, instead of only being able to expose one method and then assuming something else is going to be responsible for deciding what to call next, with just a few lines of, I always say a few lines of code, it's a few classes and a few lines of code. We've been able to say, okay, when the game context calls process, what we really need for that to do is to defer that responsibility to our handler. So then we come into our game handler, and our game handler knows that the flow of our application is to give our concrete handler a chance to handle the request. And again, in this case, it could be reverting the state, advancing the state, adding some decorations, doing whatever it needs to do. And then we're going to allow the base logic to take over, which is to load the state, display the prompt, interpret, unload state. And this is beneficial, and we'll show an example of this, because we're going to create a loop, and every time an input comes in, it's going to run through this chain. So, if I go into my load handler, what I want this to do is say, hey, if the game context, because all I'm doing here is I'll call this the player load handler, so there's no mistake. But I'm not actually loading the game yet. I'm just loading the player. Player load handler. So, if the game context dot player, oops, let me do this a little bit cleaner. I'm going to use the not operator, then string, and then is null or empty, game context player. So, if the game context has a player, I don't want to do anything else. So I'm going to say that the game context dot GameState is now equal to GameState type is equal to game selection. It's the very first thing I'm doing. Otherwise, so that way it gives me a check, right? It gives me a check later on. Boop, boop, boop. And I've only got 17 more minutes. What? All right. Let's make sure we can actually get something done in 17 minutes. Okay. And these are going to be the same way. We're going to do some sort of request checking, and if we need to revert, we'll revert. Otherwise, we'll keep going. So, where was I? Yes. So, let's go back. Now we want to populate these guys. So if I go to load player state, it's already telling me that I've got a bunch of things I need to implement, which is good. Let's just go ahead and use ReSharper to cheat a little bit. All right. So load state, I'm doing nothing. Empty on purpose. And for my display prompt, now I've got the ability to come back over to my my program, and I can say, if I'm in the load player state, then my prompt is going to be this. I've already got my interpret in here. And then I got my write line, which is my response. I do need my player, so we'll fix that in a second. And then I'm going to say empty on purpose. So, our first state's pretty simple. It's display prompt, display response. Let's go ahead and fix this, right? Because we've got a dependency issue here. And we really want to take in the context into every one of our steps, which makes sense because what would you do? You've got nothing to work with here. So over to game handler. I'm sorry, game state. And we want to say, hey, doofus, we actually need something to operate against. We can't just operate in a vacuum. Ooh, Stu brings up an awesome point that I used is null or empty, but I really want is null or white space. Good catch. The user is always smarter than you are, and it always makes a great runtime exception when someone gets a prompt and they just hit the enter, or, space and enter for whatever reason, and it whips around all of your logic, all of your super smart code. Okay. So, things are broken because we won't do this one yet. So, and load player state. Yeah, all this is broken because now I need to be passed in a game context, which is good. Yay. Okay. So we need to do that any place else we've implemented. Well, that's good. So I saved myself. Past area was correct. Past area said, don't write too much code in case you got to change something. And here we are. Thank you, past area. You are amazing. Cool. So we can see now that it looks nice, I think. We've given ourselves the ability to throw all of this repetitive code into one place, right? Which for us is really good. Because now we're really close to being able to replace all of this with just like a line of code. Or two. Actually, I think 4 is the least we can get away with. But I could be wrong. I will be wrong. We'll be wrong together. So the only thing that I'm missing right now is the user input, which I don't really care about, I guess. Or do I? Let's throw it in the flow. Let's throw that bad boy right in the flow. So instead of my handler, oops, let's go ahead and pass this guy to all of these things. So, I want to display the prompt, but then I want to gain user input, right? So this little line that I've got here, which says context user input equals read line, we're going to go ahead and make that a part of our default functionality. So when we come through this, we're going to naturally hit just this. Right? So now we're going to load the state, display the prompt, get the user input, and we're going to wait here until we have that. Then we're going to interpret that input and then unload the state. And it's going to pass to the next handler, which is our game selection handler. And if everything went well, then we'll do the same thing. We'll load the state, display the prompt, read the input, interpret, unload the state. What am I missing? I feel like I'm missing a response here. I am. Display response. All right. So what does that mean for our front end? Well, good things, hopefully. So we've got a new game context, and all of this goes away and gets replaced with context dot process. That's it. Let's go ahead and fill out the other guys real fast. So for game selection, go ahead and sheet and use resharper to implement these missing members. Yes. I'm going to copy this. Hold on, before I confuse myself. Oh, I never made a state for my game command state. Let's do that real fast. Oh. The Potato League has arrived in chat. Well, hello, the Potato League. And I think last week I saw Eshkatite hanging out in chat. I didn't even get to say hi. I missed that guy. So Eshkatite, if you're watching in the video later, tomorrow, next week, hello. Hope you're doing well. Okay. So game command state. 8 minutes, y'all. I don't think we're gonna make it. I copied all those and I still decided to cheat. It matters not. Okay. So, this load player state looks pretty good. Game command state. We want to go ahead and patch up this constructor because we already know what we want to do. We know that we just want to pass in a new command interpreter. That's pretty simple. And again, I got these 4 things we need to populate. And again, we've got load state is empty on purpose right now. Really just a example of what you generally want to do with every state. We might use it later on, we might not. Okay, so but the meat of it, right? The interpreter and the display response. Let's go back over to our program. We want all of this in our game selection for display prompt. We already have our interpreter here. And then we never really got as far as to say what happens when you the command responses, because that comes in our next semester as far as the actual game engine, once you're in that loop. Ooh, I see my name in black in chat. I'm going to check in 1 minute because that could be a great segue to the last 5 minutes of this. Okay, so, again, this goes away. Right line goes away-ish. Probably have to throw that in someplace else. But, don't care about this anymore. So we interpreted that, and presumably we now have a game library item that is... So again, the result of this interpretation should be that we have a game library item. Then we're going to go ahead and set the game using our game factory. And we want to display our response, which is you chose blank. Oh, hang on. My wife just got home. I gotta tell her.
What?
Don't eat the chicken.
Okay.
Or it's not done, so you can turn on the stove and then, heat it up. Alright. Alright, that's done. We just saved a life, people. So pat yourselves on the back. Alright, back to less important things. Alright, where was I? I'm just clicking around randomly. Okay, so then display this response is you chose whatever. Again, we're going to borrow this line empty on purpose for load state, just so we don't throw an issue. And bang. Okay, so let's get back over to this, and we will do a... Copy that, and we got one more, which is our game command state. And all we have there to really illustrate where our work's going to be is we don't have anything set up to interpret game commands. We don't really know what the response of a game command is going to be. And in pretty much every class, we don't really know what we want to do with a load state or unload state. So, as a point of note, if we decide that this load state and unload state is truly optional, which it is right now, we'll go ahead and make those virtual. In fact, let's go ahead and do that now. Because otherwise it's just clutter and it just gets in the way. So, we'll come into load state, we'll make this virtual. And virtual just means that the implementing class has the choice whether to implement or not. So we get to see why that's nice. So come back over here to load player state, and we're like, okay, that's going to be addition, intention of blank. So we can get rid of this now, and we don't violate the contract because we didn't have to override this. So now all we're seeing in our state are things that we have to or choose to override. So there's no noise. Cancel that blank. Okay, so we'll come back to our game selection state, and again, let's just get rid of it. Unnecessary. So I'll actually cover some fun things, and I'll beef up the wiki with hopefully a good link to abstract, a good link to virtual, so that you can see some of the underlying academics. And note below player state. I'm sorry. Game command state. This is definitely one where we're like, there's some things we need to do. Why look at any more noise in this one than we have to? Okay. Whew. So, all of this now goes away. And everything we saw before has now been replaced by process. So now when we hit process, let's just follow it in, because a big part of this is also making things easy to debug. It serves as a kind of facade for the game handler, which is our chain of responsibility, and it really knows how to progress through our data flow, right? And as a quick aside, without going into all of the bad code we avoided by doing this, a big benefit is this is very easy to architect. It's very easy to talk about, to display, to say that in a data flow diagram. Let's just Google that real quick. I'm just going to pick one at random, right? So in a data flow diagram, it's very easy to illustrate that this is the flow of our application. It's actually not a great one, but if you want a great one, you got to make one yourself, right? Isn't that the adage? But if you're looking at data flow diagrams and you'll see ones like this, right, that get pretty confusing, you realize that keeping things as simple as possible for as long as possible is really going to help. So being able to say, if someone says, hey, what's the flow of your module? Because you're on a big team, you're on a big project, you've been tasked with just this one module. And someone says, hey, what's the flow of your module? You can say, oh, well, the flow of my module are these 5 steps. These 5 steps every time. And so we go into the game handler process. And not only is it these 5 steps every time, there isn't an if statement in the bunch. There's no switch statements, there's no if statements, there's no clever checks or logic. It's just we march forward. And the small bits of things that we can't infer, we defer to our abstract methods and our concrete implementations. And this is kind of the basis for just good, clean architecture. So I think I can get rid of even that comment. Okay. And the only thing we're missing here is some sort of loop that waits for an exit condition, which is pretty typical in console applications. So we'd wait for the game context to be quit or whatever, and then we just dump out. But we're not going to do that quite yet. I might do it in refactor. It's not a huge part of what we're going over. Holy bananas. I'm 1 minute over time. All right. So I'm just going to hit play on this, and if it doesn't, we'll debug it. And if it doesn't work, then I will fix it after the fact, and because it should be something very minor. And then I'll make sure that my check-in is very descriptive, and then I also notate the wiki with what I did. Oops, let's try to build it. 4 succeeded. Let me go to chat. I think I want to get whatever I respond to Stu with on tape, if I even have a good answer. So Stu says, for me, I like to see you extract the calls to the console class like a facade or something. Reason being that you're directly binding the logic inside the handlers to the view, which means that it's a lot harder to change something else in the future. You could also make the load-unload state calls virtual in the base so that you only... Alright, so Stu was way ahead of us. We did the virtual suggestion. But the point he's making inside of our states is that we're tightly coupling console into our state logic, so anytime we tightly couple something, we're asking for a maintenance headache, right? We can establish that tightly coupling equals instant technical debt. I hope I'm going to remember. Let me say. So today we got for the wiki. Let's add links to virtual technical debt. Cool. So yeah, so whenever we tightly couple something, we're adding instant technical debt, observable technical debt, because we really need to architect a way to pass in some sort of rendering engine or some sort of rendering context. And that's the beauty of all these context objects, right? If we're going by this idea of modularity, then what makes up our actual application is very modular. And as long as it's very modular, we can swap out pieces. So you can imagine that we might have a render context, a game context, a user context. All these things are designed to play very nicely with each other, but at the same time they're decoupled, so they really have no idea what the other one contains. All that it knows, all the architecture cares about, is that these things satisfy the contract. The contract is the glue of our architecture. Whew. A lot of talking. Let's run this thing and get out of here. I got chicken to cook. Okay. So, I hit start on this. We wrote a lot of code and didn't check anything. So speaking of cooking, doesn't every chef tell you to taste throughout, right? We did none of that, man. Okay, so we come into the game context when we new it up. We load the player state as our current game state. Then we go ahead and load the game handler, and we seed it, right? So this concept of seeding is we're just saying, hey, I know what your first state should be. Let's not get into this chicken and egg scenario. I'm just going to seed you. And then I'm going to say, hey, let me go to a game selection handler, and let me get a command handler, and then I'll set the successor for my player load handler as the game selection, and then I'll set the successor of my game selection as the game command. That's hard to even say because of, again, it's this. And I hope this makes it onto the screen, like this linking, this chain. It's a great concept. It can mess with your brain, man, when you're trying to think about like a complex chain of responsibility. So take your time, draw it out. It'll help. Okay, and then I go to process. Hit F11 on that. I'm way down here. I hit my facade, my poor man's facade. We'll go more into that next week. Hit F11, come in, and I got my handle request. So when I hit F11 on that, because I'm in an abstract class now, make a note of that. So it's calling the base class of the load player handler. And then when I hit F11, now I'm in the player load handler. Right? And if the string is null or white space, it's not null or white space, I want to switch over. It is null or white space, so I want to keep going. And I'll hopefully do more with this decision logic as far as being able to advance or retard the state of the application and what that really means later on. Right now it doesn't do very much. Alright. Load state is intentionally left blank, so I'm just going to jump over it. That's in our virtual method. Then I want to display prompt. So when I hit F11 and go in, it just writes out the prompt. There's my prompt. So far, so good, y'all. Okay. And then I want to do a wait for user input. So now I'm waiting. Gary. Type in my user input. It goes to my next step in the flow. So far, my flow is working perfectly. Then I go to my interpreter. Hit F11 on that. Come into my state. Now my state before, we seeded that with the player interpreter. We know it's what we're always going to want, so we just go ahead and new it up. So now, I'm going to set my state as the load player. I'm going to interpret. So hit F11 on my interpreter. I just set my player as my user input. And remember, it's a very tiny statement, but every statement is an algorithm, right? We're all very smart people when we write algorithms every day. We should give ourselves credit for that. So we come back out, and we're back in our flow. Then we display the response. Welcome, Gary. And then we unload the state, right? Hit F10 on that. Ooh, what did we do? We shouldn't be out already. What happened? Excellent question. That's me talking to myself. What we forgot to do is here, I should be calling this, or just successor dot process, and then passing the game context. And so this is going to allow us, and then we drop it into the next one. It goes to the same flow again, and then drops into the next one in the same flow again. I'm not going to debug it again, but we've accomplished what we wanted to. We've been able to very cleanly outline the flow here, abstracted away from our game context, and what that's bought us, in addition to the state, and in addition to the interpreter, in addition to the game context patterns, and in addition to the factory pattern, is that when we come into our program, we now have a module. And that module, we can just load up and just hit process. So at the end of the day, we replaced all of that code that would have gotten very long and very disorderly with really sound architecture. It allows us to accomplish everything we were doing before with one call. And all of redundancy is gone. Okay, now I'm just humbragging. So that ends our video for this week on the chain of responsibility. I'll populate all this stuff along with some more links for this week's video, and then as soon as I put it on YouTube, I'll get that link up here as well. And then next week we'll do the facade pattern, and it'll be a pretty short kind of just recap week as well. Polish things up, changing the names of things, maybe exposing some more methods. But the facade pattern is a very kind of small pattern that is helpful in a lot of ways that we don't always kind of appreciate. So I'm hoping to kind of dive into that and, play around, see where we are, and plan for the next semester. Cool. Thank everybody for hanging out. Thanks to Stu. Thanks Smudge. Thank anybody who followed me. I got a few beeps and buzzes, so I know you're lurking. And hopefully if you're watching this video on YouTube or following along with the code, drop me a line. Let me know if you have any questions. All right. I'll hang out and chat for a few seconds, and I will see